Welcome friends to this third lecture of multivariable calculus. Myself Professor S.N. Chinchole from Arts Science and Commerce College Manmad. In the last lecture we have learned the level curves of functions of two variables, functions of three or more variables. The objectives of this lecture are to study the existence of limits of functions of two variables, to study the non-existence of limit of functions of two variables. First of all, the definition of limit of a function. Let f be a function of two variables whose domain D includes points arbitrarily close to AB. Then we say that limit of f of xy as xy approaches to AB is L, and we write limit of f of xy as xy tends to AB or approaches to AB is equal to L if for every number epsilon greater than 0 there is a corresponding number delta greater than 0, such that if order pair xy belongs to domain D and 0 less than under root of x minus a bracket square plus y minus b bracket square less than delta, then mod f of xy minus L less than epsilon. See, this under root of x minus a bracket square plus y minus b bracket square, it is nothing but the Euclidean distance between the order pair xy and order pair AB. And this definition tells us that f of xy is a function of order pair xy and xy approaches to some point AB. And when xy approaches to some point AB, the distance between xy and AB becomes very less, as small as possible. And when this distance becomes very less, say that delta greater than 0, then the distance between fxy and L also becomes very less, because the epsilon chosen here may be as small as possible. And that's why this definition tells us that whenever xy approaches to AB, fxy approaches to L, and hence L is called as the limit of f of xy as xy approaches to AB. Other notations for the limit in the above definition are limit of f of xy as x tends to A and y tends to B simultaneously is equal to L. This is also called as simultaneous limit. And also we can write it as f of xy tends to L as xy tends to order pair AB. Notice that, as I discussed earlier, mod fxy minus L is the distance between the numbers f of xy and L, and under root of x minus a bracket square plus y minus b bracket square is the distance between the points xy and the point AB. The distance between f of xy and L can be made arbitrarily small by making the distance from xy to AB sufficiently small but not 0. Non-existence of limit of a function. When we can say that limit of a function does not exist if function f of xy approaches to L1 as xy approaches to AB along some path C1, and The same function f of xy approaches to L2 as xy approaches to AB, means with the same limiting process of variable xy to AB along another path C2, where these two values of limits L1 and L2 are different, then we can say that limit of f of xy approaches to AB does not exist. The reason behind it is that whenever limit exists, it should be unique. Here, along different paths with same limiting process xy approaches to AB, fxy approaches to different points, and therefore in this case we can say that limit of f of xy as xy approaches to AB does not exist. Example 1. Show that limit of x square minus y square upon x square plus y square as xy approaches to origin 0, 0 does not exist. First of all, we have to denote this function as f of xy is equal to x square minus y square upon x square plus y square. See, along the x-axis we have y is equal to 0, and therefore along this path x-axis function becomes f of x0 is equal to x square minus 0 square upon x square plus 0 square. 0 square is 0, that's why we get x square upon x square is equal to 1. That means f of x0 is equal to 1 for all x is not equal to 0. So what do we get? F of xy approaches to 1 as xy tends to 0, 0 along the x-axis, because f of x0 becomes 1, and if we take here limiting process x tends to 0, this 1 remains as it is, and that's why f of xy approaches to 1 as xy tends to 0, 0 along the path x-axis. We now approach the path along y-axis. Along y-axis we have x is equal to 0, therefore the function becomes f of 0y is equal to, in the place of x square we have to replace here 0 square. F of 0y is equal to 0 square minus y square upon 0 square plus y square is equal to minus y square upon y square is equal to minus 1 for all y not equal to 0. That means f of 0y is equal to minus 1, and if we take limiting process as y tends to 0, this minus 1 remains as it is. So we can say that f of xy tends to minus 1 as xy tends to 0, 0 along the y-axis. What we get? We get f of xy has two different limits. One of them is 1 along the x-axis and other is minus 1 along the y-axis, means it has two different limits along two different lines. Therefore the given limit xy tends to 0, 0, x square minus y square upon x square plus y square does not exist. Here you have to be careful by the means of selection of paths. Here you have to select only those paths which are valid for the limiting process. Means here, as the limiting process is xy tends to 0, 0, the path should be such that the curve of that path passes through the point 0, 0. Here we have chosen x-axis and y-axis as two paths, both of which passes through the origin 0, 0. If we choose another path, say y is equal to x plus 3, then that y is equal to x plus 3 is the line not passing through 0, 0. Therefore y is equal to x plus 3 will not be a valid path for this limiting process. This is very important thing for selection of paths in different limiting processes. Second example, if f of xy is equal to xy upon x square plus y square, thus limit of f of xy as xy tends to 0, 0 exists. Here we have to select the path y is equal to mx. Again, this is a line passing through origin 0, 0 having slope m. Here m can take any value. As it passes through origin and our limiting process is xy approaches to 0, 0, this path is a valid path for this given limiting process. And along this path, what we get? Limit fxy as xy tends to 0, 0 is equal to limit of, you have to just replace y by mx here, limit of x mx tends to 0, 0 f of x mx. Now as x and mx both approaches to 0, 0, this limiting process converts into the limiting process as x tends to 0 because m is not a variable, it is a constant, it may be any real value. Therefore, this limiting process becomes limit x tends to 0 only, and f of x comma mx becomes x into mx upon x square plus mx bracket square. Therefore, limit of f of xy tends to 0, 0 is equal to limit x tends to 0, this x into mx becomes x square m, and this x square plus mx bracket square becomes x square plus m square x square, from which you can take x square as common. Now it becomes limit x tends to 0, x square m upon x square into 1 plus m square. As x tends to 0, x is not equal to 0. Therefore, we can cancel the factors x square from numerator and denominator so as to get limit of f of xy as xy tends to 0, 0 is equal to limit x tends to 0 m upon 1 plus m square, which is independent of x. Therefore, it becomes m upon 1 plus m square. Now, we get the value of limit xy tends to 0, 0 of f of xy is equal to m upon 1 plus m square. Here, if we substitute the different values of m, then we get the different values of limit of f of xy tends to 0, 0. And therefore, by non-existence of limit of a function, we can say that the limit varies as the value of m vary. Thus, we have obtained different limits along different paths, so the given limit does not exist. Third example, if f of xy is equal to xy square upon x square plus y raised to 4, does limit of f of xy tends to 0, 0 exist? Again, here we have to take the path x is equal to my square. See, this is a equation of a parabola. Again, it passes through origin 0, 0. Therefore, this will be a valid path for the limiting process xy tends to 0, 0. Along this path, we have limit xy tends to 0, 0 f of xy is equal to, we have to replace y square, limit my square y tends to 0, 0 f of my square y. Again, this limiting process my square y tends to 0, 0 reduced to limit y tends to 0, 0, limit y tends to 0, sorry, and f of my square y, it becomes my square into y square upon my square bracket square plus y raised to 4. Therefore, at the numerator we get my raised to 4, and at the denominator we will get m square y raised to 4 plus y raised to 4, from which you can take y raised to 4 as common, so that at the denominator we get m square plus 1 into y raised to 4. Now, as y approaches to 0, y is not equal to 0. Therefore, we can cancel y raised to 4 factor from numerator and denominator so as to get limit y tends to 0. Instead of x tends to 0, it will be y tends to 0, limit y tends to 0, m upon m square plus 1. As m upon m square plus 1 is independent of y, this limit y tends to 0, m upon m square plus 1 becomes m upon m square plus 1. Again here, as the value of m vary, limit f of xy tends to 0, 0 also becomes vary, means we have obtained different limits along different paths, so the given limit again does not exist. For example, find limit of 3x square y upon x square plus y square as xy tends to 0 if it exists. Let f of xy is equal to 3x square y upon x square plus y square, of which limit as xy tends to 0 has to be decided. We guess that limit of f of xy as xy approaches to 0 along different paths is 0, since its value along any line and parabolic path is 0. If we take different lines and different parabolic paths passes through origin 0, then we can observe that the limit of function f of xy as xy approaches to 0 becomes 0. To prove this, we have to use epsilon delta definition of limit, because the guessing is not the proof. We have to prove this using some criteria. Here we have to use epsilon delta definition of limit. Let epsilon greater than 0. Now we want to find delta greater than 0 such that 0 less than under root of, what is our definition? In the xy tends to AB, the distance between xy and AB less than delta. Here, instead of AB, we have the origin 0, and the distance between xy and 0 becomes under root of x minus 0 bracket square. That means it will be x square plus y minus 0 brackets square. That means it will be y square. Therefore, what we have to do? For epsilon greater than 0 given, we want to find delta greater than 0 such that 0 less than under root of x square plus y square less than delta implies 3x square y upon x square plus mod of 3x square y upon x square plus y square. This is a function whose limit we have to find, minus 0. This is our guess of limit less than epsilon. This is of the form mod fxy minus L less than epsilon. Here, in the place of fxy, we have the function 3x square y upon x square plus y square, and in the place of limit, here we have guessed the limit as 0. Therefore, we have to prove this. That is 0 less than root x square plus y square less than delta implies this 3x square upon x square plus y square minus 0 becomes 3x square upon x square plus y square, as 3 into x square and x square plus y square are always non-negative. There is no need to write the absolute value sign for these terms. Therefore, this inequality reduces to 3x square mod y upon x square plus y square less than epsilon. Now we have to just prove this thing. But x square is less than or equal to x square plus y square, because y square cannot be negative. Therefore, 3x square mod y upon x square plus y square is less than or equal to, you can replace x square, let equal x square plus y square here. What you get? 3 times x square plus y square times mod y upon x square plus y square. Again here x square plus y square get cancelled. We will get it is equal to just 3 times mod y. But mod y is not equal the square root of y square, and it is less than or equal to again square root of x square plus y square. Therefore, what we get? 3x square mod y upon x square plus y square is less than or equal to 3 times under root of x square plus y square. Therefore, when we choose delta is equal to epsilon by 3 and 0 less than root x square plus y square less than delta, what we get? This 3x square mod y upon x square plus y square, which is less than or equal to 3 times root x square plus y square, and this root x square plus y square less than delta, and delta equals to epsilon by 3. Therefore, it is 3x square mod y upon x square plus y square. It is strictly less than 3 times epsilon by 3. Means it is just epsilon. Means whenever 0 less than root x square plus y square less than delta, what we get? Mod of 3x square y upon x square plus y square minus 0 is strictly less than epsilon. Therefore, by epsilon delta definition, what we can say? We can say that limit of 3x square y upon x square plus y square as x square tends to 0, 0, it exists and it equals to 0. Fifth example, find limit x y tends to 0, 0 of x raised to 4 minus 4y square upon x square plus 2y square if it exists. See here, if we take apart y is equal to mx, what we get? Limit x y tends to 0, 0, x raised to 4 minus 4y square upon x square plus 2y square is equal to, you have to just replace y by mx here, is equal to limit of x comma mx tends to 0, 0, x raised to 4 minus 4 times mx bracket square upon x square plus 2 times mx bracket square. Again, the limiting process reduces to x tends to 0, we will get limit x tends to 0, this x raised to 4 remains as it is, minus 4 times mx bracket square means m square x square, and that's why we can take x square common from the two terms on numerator, but we get x square into bracket x square minus 4m square. Similarly, at the denominator, we will get x square plus 2 times m square x square, and again if we take x square common from the two terms of denominator, we will get x square into bracket 1 plus 2m square. Again, x tends to 0 means x is not equal to 0, and hence we can cancel the factor x square from numerator and denominator. Therefore, this reduces to the term limit x tends to 0, x square minus 4n square upon 1 plus 2n square. After applying the limit as x tends to 0, we will get limit of x raised to 4 minus 4y square upon x square plus 2y square as x y tends to 0, 0 is equal to, you have to just replace x square by 0 square here. We will get 0 square minus 4n square upon 1 plus 2n square is equal to minus 4n square upon 1 plus 2n square. Again, this is the term in m only, and m can take any real value. We can say that here limit varies as the value of m vary. Thus we have obtained different limits along different paths. So the given limit does not exist. Assignment. In the comment box of this YouTube video, there is a link of Google form for feedback assignment. For any query, please write a comment in the comment box. Thank you. If you like this video, please click on like symbol. Before it, you have to log in with your Gmail account. Again, if you want to share and subscribe the video, you can click the appropriate symbols. Again, note that you have to do such things. You have to log in with Gmail account. Thank you again.